Quantum physics is the study of subatomic particles, that is, things far smaller than, say, Trent Williams. The behavior of such particles revealed to us that the Newtonian, that's Isaac Newton, not Nate Newton, laws of physics we had come to understand did not necessarily apply everywhere in the universe. Cause did not necessarily produce effect. Actions did not create equal and opposite reactions, and, as pointed out in Werner Heisenberg's uncertainty principle, we cannot measure both the position and momentum of a particle at the same time, not least because the act of observation changes the object being measured. No organization has adapted to quantum principles more thoroughly than the National Football League and its officiating. As we think we see every week, what we saw is not what was seen by the men in the striped shirts paid to see it, and what they see is changed by the observation of the NFL's version of Heisenberg sitting in its subatomic quantum center in New York. How does uncertainty apply? Take, for example, a play from the Rams' win over Tampa. Tom Brady throws a pass from the pocket and is then hit by Von Miller rushing him from his left. Miller takes an extra step, lowers his helmet and contacts Brady around the neck, lifting his hat up and driving Brady's face mask into Brady's face, busting his mouth open. Brady, living in a Newtonian universe, was visibly upset at this demonstration of cause and effect, and turned to the referee Sean Hockley to remonstrate. Hockley, of course, was standing behind Brady and could not have seen the moment of contact unless he had X-ray vision, which is a thing of comic books, not physics. But umpire Larry Killens was to Brady's left a few feet away, staring right at him throughout the incident. Midway through Brady's arguing with Hockley, Killens comes running over, appearing to shout at the two men, and Hockley throws a flag and penalizes Brady for unsportsmanlike conduct, his first ever such penalty in a 22-year career. Now, we saw Miller hit Brady after we saw the ball leave Brady's hands, but we were not in the perfect position like umpire Killens, and he saw no such thing. Were we victims of Heisenberg? Did our watching the play alter what happened? Or did the same thing happen to Killens? At the risk of confusing you further, was it like the paradox described by Erwin Schrödinger discussing his famous cat? When the quantum world interacts with observation, an object might exist in two states. Not California and then Nevada like the Raiders, but like Schrödinger's radioactive cat, both dead and alive, until the feline status is determined. So Brady might have been both fouled and not fouled, and thus, by questioning the very nature of the NFL's quantum existence, he had to be penalized. Schrödinger created his paradox after reading Einstein's criticism of quantum theories, but the NFL has listened to Einstein as well. For example, we know from Einstein about ways time itself can be bent, one instance of which occurs regularly in NFL games when timeout is called on the sidelines as the play itself starts, but the play is then stopped and the universe switches to timeout, in which the play never took place at all. An even more perplexing incident of this time slowing down was demonstrated in the Rams 49ers game. 3 times the play clock clicked down to 0 before the Rams could snap the ball. 3 times the play continued with no call for delay. 2 of these occurred on possessions in the fourth quarter, which bracketed one by San Francisco, in which the same phenomenon occurred, but the play was stopped and a penalty called. Time slowed down for the Rams, but speeded up for the 49ers. Scientists have speculated that the gravitational pull exerted on referee Carl Scheffer's crew was affected by the weight of the big bodies on the Rams' O-line, while Trent Williams, like Schrödinger's cat, either existed or didn't. In the NFL's quantum universe, even the basic laws of physics both do and don't apply. Consider this moment when Jimmy Ward's helmet and Odell Beckham's head are proven not to be able to share the same place at the same time, and a penalty ensues. Nothing could be simpler. Yet consider a similar moment when momentum and location could intersect and 2 objects occupy the same place at the same time without problem. When Ben Skowronek's helmet and Trenton Cannon's head meet, as Cannon stands, watch Cooper Kupp take a fair catch. This contact posed no theoretical problems for the officials. Which leads us to the greatest problem of NFL physics. When is a catch a catch? Once upon a time, it was a simple Newtonian equation. Ball in your possession, both feet on the ground, catch. But in the quantum NFL, where nothing is what it seems to be, things can be different. Or the same. At the same time. Or maybe not. Consider this catch by A.J. Green in the Cardinals' playoff loss to the Rams. Green catches a pass from Kyler Murray, and as he turns, he sees a hit coming and takes a hop step to protect himself. Nick Scott hits him and forces a fumble which goes out of bounds. Pass and fumble if you're Isaac Newton. And after much discussion, the officials agreed with Isaac. But then Sean McVay deposited his challenge flag daintily, and just like entangled photons, which can act simultaneously no matter how far apart, McVay's impulse and the impulse of Al Riveron in the nucleus of the replay shell in New York coincided. That defensive hop by Green did not actually occur. There was no action common to the game, or what is called a, quote, football move. In other words, the momentum and the position of the possession of the object being observed were changed. Heisenberg's quantum universe had prevailed, and we were back to the beginning, and the Rams were back in motion to a Super Bowl in their own stadium. Hey, thanks for watching. If you enjoyed this video, why not check out our pieces on Joe Burrow or rookie sensation Jamar Chase, just in time for the Super Bowl.